Power drain. Power drain. Opens the door to. Opens the door to. Got the green light. Got the green light. Cracked it. Cracked it. Technical edge. Technical edge.
All right, you hear it absolutely everywhere these days, right? Everything's got to be AI powered.
It's the buzzword.
Totally. But how do we actually get that AI power everywhere? You know, into the devices we actually use every day, not just stuck in those giant, pricey data centers.
That's the multi-billion-dollar question, isn't it? How to democratize it.
Exactly.
Yeah.
So today we're doing a deep dive into something that might just be the answer. It's a new memory tech called SOCAM.
System-on-chip attached modular memory. Quite a mouthful.
It is, but it could be a huge deal.
Yeah, so our mission today is basically to unpack what SOCAM actually is, why it matters so much for AI's future, and crucially, where the big players are at.
And for many of you listening, especially if you follow the big Korean tech companies, well, the current situation our sources describe might raise an eyebrow or two.
Definitely some interesting dynamics at play.
Okay, so let's get into it. SOCAM. It's basically NVIDIA saying, we need a different approach to memory, a pivot.
Right. Away from just relying on high bandwidth memory, HBM's great, super powerful.
But yeah, it's expensive.
Yeah.
And integrating it widely, that's tough. Really limits where high-performance AI can go.
Exactly. SOCAM is designed to be, well, smaller, cheaper, and just much easier to scale up or down, more adaptable.
And the tech behind it is pretty clever, isn't it?
It really is. They're using LPDDR DRAM, that's the low-power stuff, usually in your smartphone.
Okay.
But they've optimized the heck out of it for bandwidth and energy efficiency. The source mentioned it's like 2.5 times faster.
2.5 times, wow.
Yeah, and it only uses about a third of the physical space and a third of the power compared to typical server memory modules.
That's a massive difference. So,
Yeah.
Okay, what does that mean for you listening?
Well, think about your next PC being seriously AI capable, or other devices having near HBM level performance without the HBM price tag.
Right. It opens the door to putting really powerful AI into way more places. Less cost, less power drain.
It's about making high-end AI more accessible.
And NVIDIA isn't just talking about this, they're moving fast. The source says they want to ship, up to 800,000 of these SOCAM modules?
This year alone, 2025, that's a pretty aggressive rollout plan.
Okay, so here's where it gets really interesting, especially thinking about the big memory makers.
The competitive side.
NVIDIA's been working with everyone, right? Micron, Samsung, SK Hynix. They started collaborating back in, 2023 on the standard.
Correct, co-development. But here's the kicker from the source. As of late July 2025,
Yeah.
only Micron has actually gotten the green light from NVIDIA for volume production.
Wait, only Micron? So what about Samsung and SK Hynix? I mean, they're giants in memory. This is surprising.
It is. According to the source, they're still stuck back in prototype testing, not ready for mass production yet.
Still testing? Why the delay?
Well, the source speculates a bit, particularly about Samsung. It mentions their recent trouble passing NVIDIA's validation for HBM3E, that's the next-gen high-bandwidth memory.
The heat and power issues we heard about.
Exactly. And that failure, the source suggests, might be casting a shadow over their ability to get SOCAM ready quickly, too. Raises questions about their yields or thermal management for these new designs.
So Micron somehow cracked it faster? What was their edge?
It seems technical. The source points to things like alternative wire bonding techniques and different thermal designs, basically smarter ways to connect the chips and keep them cool.
And that allowed them to pass NVIDIA's tough validation process quicker.
Apparently so.
Yeah.
Gave them first mover advantage, got the early approval.
Okay, so Micron's got a head start. But you have to wonder, can Samsung and SK Hynix catch up fast? They have massive resources.
That's the big question, isn't it? It's not just about the memory chips, though. SOCAM needs custom PCBs, the boards they sit on.
Right, that changes things for substrate suppliers, too.
Absolutely. So Micron getting out the gate first gives them a strategic edge as the whole supply chain starts shifting to support this new standard.
And yeah, maybe 800,000 units sounds small compared to the millions of HBM units Nvidia uses.
It is, for now.
Mm.
But the potential impact is huge. If SOCAM takes off.
It could fundamentally change where we find powerful AI.
Exactly. Zooming out, like you said earlier, this could be the tech that pushes AI truly out to the edge, into consumer gear, into everyday devices, not just locked away in data centers.
And right now, in this critical phase, it's Micron setting the pace, not the players maybe everyone expected.
It's just fascinating how fast things can change. You know, a new standard comes along and boom, the competitive landscape gets reshuffled.
Definitely gives us, and you listening, something to think about. Can the established leaders adapt quickly enough in this accelerating AI race?
Yeah, it really highlights the pressure and the speed of innovation right now. It'll be interesting to watch how this plays out.